Humility. All right, number 2, 64 feet per second. We got it? Number 4, final answer is 128.16. You guys should be doing 3 decimal places. Ignore their silly 2 decimal places. Where'd you guys leave it in? Oh, you guys didn't do the pre-cal thing first? Did it not say to do the pre-cal thing first? The final answer is 128.
Find speed at t equals 4 seconds, and then it says confirm algebraically, but I don't know what that meant.
Yeah, what does confirm algebraically mean?
I just did the
Confirming algebraically is the idea of taking the derivative, basically. The limit as h approaches 0. That's the confirm algebraically. And at 4 seconds, we said the pre-cal way is like literally close to 4, so 0.01 or 0.001 or 0.001. It's fine. 128 feet per second. I know sometimes it's harder that we're starting knowing everything that we know. I know. Number 10. 5. Good?
Wait, number 10? Yeah.
Number next one.
Oh, wait, actually.
13. Oh, I mean, so, wait.
Wait, I had a question about that.
Hold on, Isa. Aryan, go.
For number 10, it says use substitution, but I don't like why did you need to use substitution? Let's leave it 0 or 0.
What? You just plug it in, eh?
Right, but it's in the directions it said do substitution, right?
You just plug it in.
That's all it meant? I thought it meant like substitute. I wasn't sure what the directions were. That's what I did.
That makes sense. They're just giving you a hint as to, right, they're giving you a hint. Because a lot of people would look at that and be like 0 over 0 and start factoring and then not even realize that it wasn't. Shh. Consider it, we get it. We're a level above and so the easy stuff gets hard. Isa. I mean, you can check the quick review if you want. That's good. You might want to peek at the other ones. It shouldn't be a big deal what you missed, but I'd peek at them. Sorry, 28. Thank you. There he is. Final answer is -1/4. You could have either solved the limit using simplifying the complex fraction, or you could have taken the derivative. You should have let the denominator be to what power? I would have made it to the -1 power. What'd you guys do?
Oh, I did. I did the complex fraction too.
Oh, you did the complex fraction? Okay, never mind. You guys are all amazing. Oh.
No, I did. I take it back. I just canceled out the x's.
Yeah. I think complex fraction would have been way easier than L'Hopital. Yeah. Okay. Careful. What would have been true? What animal would have died if, just because I see it in calculus, if I didn't see it in calculus, I wouldn't show you. Who are you? I don't want you. Oh, I stink. There we go. Oh man, it was working just until right now. Where am I? Oh, there I am. What would happen if you did something like this and we're like, yay?
That's what the kitten does.
Yeah. Don't just go crossing off. Or it would be like, yay, x and x. Now some of you were like, the x's did cancel out. I don't know what's going on. The x's did cancel out, yes, but only because the 2 minus 2 is 0. But then you should have had a -x with a -1 on top. Just be careful of the algebra. Be careful of the algebra. Okay, what else? Thank you. Number 42. -1. I know number 42 is only for x less than 0, and so the answer was -1. What's going on for x over absolute value of x if you're coming from above 0?
It's just like 0.1 over 0.1.
Or 0.01 over 0.01 or 0.001 over... What are all of those reducing to? +1. So what would the limit be, the two-sided limit of that function? dne. Like if it was a two-sided limit. This one's only one-sided, so you were fine. -1 was the proper answer, but just reminding you that absolute values with limits frequently do not exist. Sorry, next one. Oh, he starts down here. Ready? True, false, false. True, 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 true. True, false, false. All the rest are true. True, false, false. True, 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 true. True. Yeah. $44. Is this better? Okay. Number next one. C? Okay. Hold on, we're on 2.1, right? C says the limit as x approaches 2 of f of x is 2. Oh, got it. The graph looks like you have to remember what a limit measures. So for letter C, f of 2 is 2. The at, where is the function? At 2. But the limit is all about not the at, but the approach. So what should the limit have been? 1. Yeah. That's that nasty case when you have the hole and then you get confused by it. Okay, number next one. 60 even? 60 then 62?
60.
Okay, cool. Number 60. The limit as you go towards -1 from below and from above is the exact same thing of 0. This is the same case of a hole. And remember, it's not about the at, it's about the approach. That's a really nice graph on a graphing calculator. Do you guys see that? It shows the hole and the point. I don't know. Wouldn't have been my graphing calculator. Maybe it's a computer program. Anyway, does the limit exist? And the answer is most definitely. What is the limit? 0. Is the function continuous? At 2. Sorry, at -1. No, the function's not continuous because f of the limit, both are headed to the exact same diner at 0. It's just not serving breakfast that day. All right, anything else besides 60? Any questions on odds that you guys were able to check?
I love this homework.
55. 55 was all about properties, so it got, oh yeah, it got a little bit messy, I won't lie. Let me take a picture of white space, that way I can just use it. Give me a sec, and whoosh. Sorry, Mrs. Christensen changed a setting, and so now I can't write on top of any windows anymore. Yeah, but she's busy, and I could undo it if I was an admin, but I'm not an admin. Okay, 55 gives us, Riley, you have it, gives us a couple clues, right? Okay, keep going. This is all about properties of limits. So then letter A. Is it g of the quantity x plus 3 or g of x plus 3? Okay. Kiddos, real quick, what transformation is happening to g if there's a plus 3 on the outside? It's a vertical shift up 3, right? If it's a vertical shift up 3, then what's going to happen to the y values it was approaching before? It's going to move up 3. So you can think of, this is technically from properties of limits, that with addition or subtraction, we can take the limit of one plus the limit of the other. Or thinking about it, if the graph shifts up 3, the y value shifts up 3. So 6. A couple different ways of getting there. Letter B. All right, Justin, explain it.
Alright, so first you have to look at what the limit of f of x is as x approaches 4 to 0, and then you just plug in the 4 at the x. So that's 4 times 0.
And technically the property lets us look at that. So we're not saying that f of 4 is 0. We don't know that for sure. Kind of like the whole idea. Maybe that's not what f of 4 truly is, but that's what the limit is. So we can use the property where we can split up and take the limit of one times the limit of the other and say, sweet, 0 times anything? But if the AP question was to say something like, what's f of 4? I don't know. You didn't tell me it was continuous, so how do I know the limit is the value? Just wanted to make sure you didn't get that confused. Because usually we'd say plug in 4, like 4 and f of 4, but we don't know. But the limit property lets us actually just take the limits. What's C?
When we have x equals 4, g squared of x.
Like that? Arian, keep going a little bit louder.
You can just separate it so that that's purchase for g times x purchase for.
You could think of it as multiplication, g times g. Or there actually is a property that lets us do a composition of functions. Because it technically is an f of g, f of h, I guess, because the g is already in. Where you have the g inside the squared. We can actually, as long as the function, ooh, did they say the function was continuous? I have it right here. Well, they didn't tell you that. The book should have been a little bit trickier, a little bit more precise. As long as you're within the domain, which technically you are because you're not going to any other x values, I guess you're okay. But you can actually bring the limit inside. So yeah, either way. Limit of or the limit of g squared. Either way you get. Last one. Has to be that way, right? So the nice thing is with limit properties, as long as you don't have a 0 in the denominator, there's the quotient property, the limit of the top divided by the limit of the bottom minus the limit of 1. Like we can literally split that thing up all over the place. So that's why you end up with 3 over 0 minus 1. It's totally legal, totally valid. I mean, negative 3. You guys agree with all of them? Okay. Not quite as tricky as an AP would do, but definitely at least getting you thinking that direction of how the properties work. Anything else, odds or evens? How many of you guys would say this took you less than 45 minutes total to do? Sweet. Okay. All right, section 2.2, let's go have some fun with limits at infinity. If you guys think about it though, like last year's sections versus this year's section, in section 2.1 we reviewed the beginning of rates of change, which was a section in and of itself. We reviewed limits numerically and graphically, which is a section all in and of itself, and then we reviewed limits algebraically. So 3 sections in one. Just gives you an idea of why, once again, this book is very different, and why I have not chosen it as an AB book. Even though in some ways I would love for AB not to have calc chat, I don't lie. It's nice if you use it well. It's bad if you use it poorly. All right. Oh, I didn't have you go in your workspace. That's okay. Today's chapel day. We'll do that one tomorrow. Okay. We'll do that tomorrow then, since it's not the right one. Here we go. Limits at infinity. Let's just bust into it, because this homework's supposed to be due tomorrow. Limits involving infinity. Last year we said limits at. That's even how I put the title on the board. I'm sorry. Limits at infinity. I like limits involving. I like this book's way of doing it better. Limits involving infinity a bit better. So as x approaches positive, do I have to connect the plus minus with plus and minus, or plus or minus? Why do I have to do plus or minus infinity? You can't be going both directions at once, yeah. Now, does that mean that the answers won't be the same? Not necessarily. But once again, they don't necessarily have to be the same. They could be the same, but they don't have to be. I think we did. There's a little multiple choicey quizzy thing. Oh, we didn't write this down at all, did we? I don't think we wrote down this one. I don't think we wrote that one, did we? I just left off a slide. I didn't mean to. I'm sorry. Huh. We talked about infinite, and then I just stopped. Okay, for most of us, it's okay, but at the very end of this section, sorry about that, guys, section 2.1. Oh, I did talk about forever cards numbers 1 through 3, I think, but then I didn't actually, yeah. There is an extra one down here at the bottom, which I do want you guys to add to your forevers. It was totally unnecessary for last year, as far as I can tell, for CalcAB. I've never seen this one come up. But it is going to be necessary for CalcBC. It's not the only time we'll see it. If you guys can't see it, let me page with it. It's the limit as x approaches 0. That half helps and half doesn't. There you go. Limit as x approaches 0 of 1 plus x to the power of 1 over x equals e. Super weird. You might be like, what on earth? If you were to plug in 0, it would be 1 to the infinity, and 1 to the infinity is actually an indeterminate form. It's not 0 over 0. It's not infinity over infinity. You can't use L'Hopital's unless you were able to get it to look like 0 over 0 or infinity over infinity. You can think about it as defining who E is, which is kind of crazy, because E shows up in so much of nature, so many things of exponential growth and decay, compounding interest, continuously compounding interest. All sorts of crazy stuff. But anyway. So these two you have from last year. And then even the kids who have their forever cards, add number 3. Okay? Thanks, Maggie. Isa. There was the vertical asymptotes, infinite form, number over 0. Did you get that one? Check the signs? Yeah. This was just the last page, and then it was there. I thought we were done, and I just didn't give you time, I suppose. I'm sorry. Anybody still writing? Oh, a couple more seconds. Okay, as we go to infinity, there we go. As we go to positive infinity or to negative infinity, remember to the right, to the left. We could either have the limit equaling a constant L, positive infinity, or negative infinity, or dne. And I want you guys to work together as a class. I'm going to be completely quiet for about 2 minutes. I want you to see if you can fill in for every single one of these cases the limit as x approaches positive or negative infinity. And you can make them as creative as possible. A function where at least one limit will be L. I'm not saying both have to be. Where at least one limit will be L, then tell me, okay, what's the limit to infinity and to negative infinity? Maybe it's the same, maybe it's different. If you make it creative, it'll be different. And then what's a function that would have an infinite answer as you go to positive or negative infinity? It has to show up somewhere in one of these. Maybe in both, maybe just in one. Negative infinity, maybe in both, maybe just in one. And then dne, maybe in both, maybe just in one. Ready, set, who's going to lead the discussion? James Calvin, you're in charge. Come on up to the board.
Okay, so I guess we need a function that, like when we write as limit approaches infinity, it's going to be the limit will approach positive infinity and then negative infinity. I don't really know what L, I guess L is.
What do you guys think? What's L?
actually, no, it's not. I'm kidding.
Or
No, it is.
1 over x will be 0 as L, right? Yeah, for L, can we do 1 over x for that? Yeah, they go to 0.
That would be DE, no?
But it would change it. I agree.
Yeah.
I think you're right.
Just the polynomial section.
Yeah.
Why don't we do?
Wait.
Why don't we
It
do
has to
something
be
with the
negative
Outside the
denominator?
parentheses.
So it's upside down.
Okay.
Because
Yeah,
the other
outside.
would be like that. Should I want to
Squared.
just make it nicer.
This one.
Squared over like
Yeah.
This one.
2x.
Yes.
Oh boy.
Like what?
So just any function of the
These are just functions, right?
Yeah, that's what I'm confused about. Okay, all of these functions. So I'm confused. What is the first one? Let's do all.
L. L is the whole.
Wait, does the cosine and sine ones have to be made? Because they also make, right? We could already talk.
Oh yeah.
That's what I'm confused.
What is that?
What are we talking
Yeah.
about?
It says it approaches infinity, but don't all of them
There's
approach
no
infinity?
limit.
Oh,
Yeah.
I was like, is it also between 1 and 0?
Yeah, you're right. No, you're right.
Oh yeah, that's a good one.
I think
So Kathy said a good one for the
Cosine.
approaches infinity.
Cosine.
Cosine x.
Would it be the function or would it be the function?
Now I'll tune in for just 1 second. So you guys have correctly, you've chosen functions, and here's the idea. In order for you to prove to me that you're right, take the limit to infinity and to negative infinity, answer it for each function, and if L, a constant, shows up in your answer, you did it correctly. It doesn't have to be in both, it has to be in at least one. If positive infinity shows up at least once, if negative infinity shows up at least once, if DNE shows up at least once. Does that make sense?
Yeah.
Solve the limits, one by one.
Okay, that's fine, but then I'm confused about the other two. What's the difference?
Solve for the limits first.
Okay.
Okay, I'm being quiet, go.
Start with
Yeah, start with L.
So
Isn't
if
it
we plug
just
in
0?
infinity, that's 0.
It's just 0. Number over 0.
No, it's like
No,
this.
because it goes
And they
like,
both keep going into like approaching.
and they never
Yeah, but they're both going to 0. Right? Am I wrong?
It's in the rubber cards. It's like one of the basic graphs that we have.
Yeah.
Yeah, so there's just draw a line between it. They're never going to touch that line.
Because yeah, 1 over x is.
It looks like this. It looks like this.
Okay.
Yeah, so there's no limit. Yeah, it's going to be a line.
Oh wait, that would be an infinity, wouldn't
Okay,
it?
that's okay.
No, no, it is infinity. You're right. No, you're right. It's positive.
I was thinking of because it's
Not 0.
an
It can't
infinity
be
one
0.
because we're talking about the white.
It's going to be zero.
I'll give you a share.
But is it when you
It's
go
not
down,
zero.
you can go up? So
It's not 0. I was thinking of the x value.
It's
It's not y value.
Why don't you guys skip that one? Skip the first column, go to the second one.
Erase it. Just get over the eraser. Just go.
Okay, so we're positive infinity 1. Okay, what's the limit as
Yes.
x approaches infinity?
positive infinity.
Okay, guys, we're 1 for 1.
Positive infinity is infinity. Negative infinity is infinity.
So,
For the same one, are we just doing it for all of them? Or
As the limit as x approaches negative infinity, you're saying?
for the second polynomial.
Wait, if we plug in.
The second one.
Wait, I got a
If
question.
a function approaches negative infinity, it's infinity. Are we
So
doing
just
that?
go right under
yeah,
it.
yeah.
Yeah.
It's infinity. Yeah.
Oh, that's not what I thought.
Okay.
Oh no.
Wait, I'm having.
That's not right.
Yeah.
Wait, is that what is that 3x? What's the power?
As
of
x
It
is
is. Look,
approaching.
see, look, it is.
No, I know it's a parabola. I get that. Oh, I guess.
Approaching.
But it's like coming down from this way, and then never mind. Forget it.
Wait.
They're
No,
both
that's
infinity.
an odd function.
What?
As approaches infinity, it's negative. As approaches
Yeah, I think we're good. I think it's fine. I think the last three are fine. The first one needs some work.
Yeah.
Yeah.
but the endpoints.
Oh, we're talking about endpoint.
Yeah.
The last one is D.
Right, because they also
Yeah. Okay, we could change the first one to
Wait,
a
so we
log
just
formula.
answered our own
Because
question?
log is like logistic growth, right? Like, doesn't it have like a cap, like a that and just like make it more simple.
I don't know
Do we need a
what it looks like.
constant
I can't remember what the parent
Oh, log is
Because if we do,
Oh, just like this.
just like this. And
But I'm pretty sure it's
wait, what is it?
infinity
Okay,
for
no.
both of them.
I think log.
Kathy has a question.
What does the L represent?
Just any like.
It's a
There's a
horizontal
forever
asymptote.
card on it.
Yeah, remember the forever card?
What
Once
about
you
the
get
forever
approaches L, then it's
It's any asymptote, so if it's like stuck at a value, that's what.
it's a horizontal asymptote.
So this one, if the graph is like this and then like this, right?
Yeah.
So to
Okay, so what,
infinity
yeah,
is
to
there's
express
no
it
L.
is the limit as x approaches negative infinity as x equals L.
I think it's that.
Okay.
Yeah.
Either
Right, but
x,
it's-
that's what I was thinking.
But
It's 0 and 0. Well, as it approaches positive infinity is 0, then for negative infinity is heading towards 0 also.
so I was right.
So you
So you're right.
As it approaches negative.
Wait a second.
Okay, wait, were we right or not? I'm confused.
Finish it up, James. What do you think? Yeah.
Okay, Riley.
This is how bad things happen. So you had it right, and then like one person was like, but, which is good to question, but then all of y'all weren't like solid enough, and you're like, oh yeah, yeah, it's wrong. Okay. Pause. 1 over x, all right? No. You were confused in a sense for a good reason. You guys just weren't keeping in mind what the question was actually asking. You were totally right, all of you that convinced yourself that you were wrong, that the function does go like this. But you all started focusing on the wrong thing. Everyone who thought they had just made it wrong, like, no, it's infinity. What were you focusing on? You were focused on this. You were hyperfixated on this. But here's the problem. The whole point of the problem was going to infinity and to negative infinity. So going to the right and going to the left. Did this have bearing on it whatsoever? No, there's like a huge life lesson in that. But for right now, we'll just say, what's the function doing as you go to the right? Going to 0. As you go to 0. Does that mean that this should be like totally disregarded and forgotten for all of eternity? No, like it's important. It's important to know what it looks like, but did this have any bearing on the actual question? No, not at all. Okay. So you guys did pretty good. 0, 0, infinity, negative, DNE, DNE. The AP would probably only ask this one, using you as you go to infinity. But otherwise, they probably would have had ones where these weren't always the same, just to make life a little more exciting, maybe throwing in like square roots of squareds or maybe like absolute values or other fun things. This is not always true. What one does is not always what the other one does. We know that kind of, right? Okay. Horizontal asymptotes, ironically, it's you guys are quoting your forever card. It's right down here too. It was really funny though. I was super entertained. We should do this more often. Anyway, just wait until it's your turn to be up here. Good job, James. Thank you. He was managing chaos. You guys got it? Okay, so horizontal asymptote will only exist if the graph is leveling off as you go to infinity or negative infinity. Justin, you were trying to kind of explain that. You can use the word stabilizing, you can use the word leveling off, you can use the word approaching a constant, but that's what the L was. It was just some constant, it was just some limit. Yeah. Yeah. No, I trust you. I think I made it once upon a time. You guys still going? You threw it on the ground. That's an old one. Did I ever tell you guys about the book drop that a class tried to do on me? Oh, you guys don't really do fun things with. Never mind. Just kidding.
We can be fun.
Like entertaining but not destructive or disrespectful pranks on teachers.
Tell us about the prank.
It was Karen's class actually. They decided that they wanted to do a book drop and they had like an actual time on the clock that they were going to all drop their pre-cal books, or was it calculus books on the ground. It was the worst thing ever. You think it would be easy, right? Like just like when the second hits and everybody does it. No, it was like thump, 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 thump. Oh, thump, and then I was like, that was bad. You heard the adjectives I gave though, right? It was entertaining, respectful, non-destructive. There's not been a senior prank that's been done in the last, well, ever since I've been here, really. No, one was somewhat entertaining. Oh, that was kind of mean, though. There's been like one in the last 10 years that's been actually those three things, and the rest of them deserve punishment. No, that was a long time ago. That was a long time ago. That was before me. But, or there was the one that let.
I saw that on like internet.
We probably shouldn't have. Okay, one was true, and that was bad. There's been some destructive ones in the past. That's why there's so many things, because so many rules against it. But that was like a silly one for the counselors. Yeah, I mean, they did that prank. That was entertaining and funny. So if you could think of something entertaining and funny to do as a, but anyway. So anyway, coming back to something that we're supposed to be doing. Squeeze theorem. Squeeze. Squeeze theorem is something that we talked about for about 2 seconds last year, and then we moved on. It wasn't a forever card. It wasn't needed to be memorized, et cetera, et cetera. And it's not going to need to be now either, except homework is going to make you dig just a little bit deeper into it, because it is really, really useful. It makes the impossible possible. So does L'Hôpital's, but L'Hôpital's isn't always, I know you do. L'Hôpital's doesn't always do exactly what you need it to do. So even though the squeeze theorem itself, you guys don't have to memorize and have to be able to totally state word for word, et cetera, et cetera. Thought we could do it in one, but nope, we needed two. Homework's due on Wednesday now, not tomorrow. You're going to be using this more for polar, for sure, but it's going to be helpful here. Does it make sense if I put the following, that 1 minus cosine of x all over x squared is always going to be less than or equal to 2 over x squared, and always going to be greater than or equal to 0? Do you guys agree with that? Why do you agree? Yeah, 1 minus. Just cosine of x over x squared, but 1 minus what is 0? 1 minus 1, and cosine will be 1 at 0 and at 2 pi and at 4 pi. Cosine can be 1, right? But then cosine can also go from 1, its maximum, all the way down to -1. And so if cosine goes between 1 and -1, then just using those values as my guide, I'm going to go between 0 and 2 over x squared. And why is that helpful? I don't actually, and you didn't actually ever have to really solve this by hand. If you had seen that it's always between 0 and 2 over x squared, then what's going to be happening as the, or if I take the limit as x goes to infinity of each of these n's? Well, what's the limit as x goes to infinity of 0? Oh no, 0. What's the limit as x goes to infinity of 2 over x squared? So what's squeezed in between? So his limit has to be 0, regardless of whether or not I can show it based on the function itself, because he's squeezed in between those two and they come together at 0. Anyway, dun dun dun. P.S. Degree test. You guys should have known the limit as x goes to infinity of 1 over x is 0. The bottom wins. All right, get out of here. Start homework 2.2. If anybody else has corrections by the end of today, I'll still take them.